The recording. Hello. This is the Pack and Rat, um, a simulator character that walks around with a penguin on his shoulder and a cowboy hat. Luckily, this is a 3D virtual world. The cowboy hat would have probably killed the penguin by now in real life. An avatar that's supposed to look like me, made by a person who actually has never seen me, but it works. Alright, so what we're looking at is um, concrete drums of sorts. Basically, it's a ring of concrete impregnated fabric that's been filled with basic dredge from the ocean and lifts up a little area of earth in into the intertidal zone. So obviously we're at median or half tide um, at, at this point, and this is where the mangroves would be planted, although we probably get the propagules developed a little bit before we put them here. The burrows might be filled mostly with rocks and stuff. We really want things that the propagules can get their little roots down into, and then that becomes an ecosystem where other kinds of saltwater surviving vegetation can develop, as well as a vegetation that may hang on the tree, mosses and other things, depending on the amount of rain in the area. Off the coast of Nigeria, I'm thinking we can have we can have air-based plants that absorb moisture and rain and things like that. There's also a possibility of creating rain reservoirs within each planter so that freshwater life forms can survive between storms. Storms will generally contaminate any kind of rain-fed fresh water that you have, and so that aspect may have to be regenerated after a storm. Now this arrangement, these plants should end up with 30-foot diameter branches reaching out. I think I have some plants in the distance there. I'm not sure what they are, but they so there should be a fairly good coverage of foliage. In other words, the bulk of the sunlight falling on the area will hit something green, and the leaves will fall into the water, and then this organic carbon in the water should be able to feed a healthy layer of seagrass and coral and other life forms that we have to make it a point to make sure are in fact there. So this gives you an idea. Remember, this is mid-tide, so at low tide we're in maybe a foot or two of water. At high tide, depending on the depth of tide. In Nigeria, the tidal depth is very shallow. They do not get very steep tides from what I've been able to determine. But they get enough tide for mangroves to survive wonderfully if they're sitting at the right elevation. Um, these platforms, over the next 50 or 100 years, they will grow up because they will create biological mass that will cause them to become taller. And the root system of the plant will create a larger pile than this. That's actually good because that allows them to survive into a significant amount of sea level rise, at least a few feet before all is done. And of course, you can come and pump some more rocks or something on there if necessary, so that we have at least 100 years of sea level rise potential in a field like this. The productivity will show up in the form of sea life, fish and such, because we're feeding organic carbon into the lower level of the food web. We should be able to see should be able to see a couple of kilograms, a couple thousand kilograms per hectare of sea life productivity. And that, of course, is improved if you get a good, healthy seagrass going, particularly if we use artificial illumination or light pipes. Light pipes are just rods of glass that you um, poke into the water. The top of the glass is exposed to sunlight, and it transfers light deeper into the water and allows seagrasses to grow more intensely at greater depths than they would normally grow. Um, and so you can create a lot of CO2 to organic carbon conversion, be it carbonate within the water or atmospheric CO2. Um, and all that organic carbon gets eaten by something, which eventually, in many cases, gets eaten by us.